I want us to look at resolution of vectors. We've solved problems
This
on
call is now being recorded.
we've solved problems on vectors that
This
are
call is
inclined
now taking notes.
on vectors that are inclined at an angle. We've also solved problems when the angles is 90 degrees. And today we want to look at how we can bring vectors that are of various components into just two components. That's the whole idea about resolution of vectors. We'll be given a system of vectors inclined at a point where we'll have various vectors inclined at a point, and you'll be given their angles of inclination, and you'll be asked to resolve the vector into just a single xy component. And that is what we will do in today's class. But before then, recall that I said the resultant vector will only have the same effects as the original vectors in both magnitude and direction. Just have it in mind that the reverse process of finding two vectors which have the effects as the resultant vector is what we call resolution of vectors. That's it. I repeat, I said have it in mind that resolution of vectors is simply the reverse process of finding the two vectors which will have the same effect as those other vectors. Do you understand that? Which will have the same effect, please, as the resultant vector. Remember, in resultant vector, we say a resultant vector is a single vector which will have effect in both magnitude and direction as the original vectors that are acting together. Now, that reverse process of finding those two vectors that will have the same effect as the resultant force is what we call resolution of vectors. So have that in your mind. Now, take note, suppose that we have a vector, let's say vector f. So remember, I gave you examples of vectors. It can be velocity, force, acceleration, as many as that. So the name might not really matter much in this aspect, all right? But have it in mind that vectors include velocity, acceleration, weight, force, and the rest of that. Anything that has direction and magnitude is a vector. So let's say, suppose we have a vector f that is inclined at an angle theta to the horizontal. So let's say I have a vector f inclined at an angle theta to the horizontal. So this is my vector inclined at an angle theta. Now let me try to sketch my vertical component. It's still part of it. Now the vector that can be resolved, this particular vector here can be resolved into both horizontal and vertical components as long as the angle is inclined to the horizontal. As long as the angle is inclined to the horizontal component of the vector, of this vector f, this is vector f here, the horizontal component of this vector f can be given by fx equals f cosine theta, while the vertical component of the vector can be given by fy equals f sine theta. So take note of that. Have it in mind that these formulas, they are only valid if the angle of inclination is to the horizontal. But if the angle of inclination is to the vertical, then my fx becomes my fy becomes my fx. So if you must keep up with this formula, you must ensure that the angle given to you is inclined to the horizontal. It is making, the angle must be made with the x-plane, the horizontal line. So if that is the case, the horizontal component of the vector, in this case f, so f of x means horizontal component of the vector. F of y means the vertical component of the vector. So if the angle is inclined to the horizontal, my f of x simply becomes the f multiplied by the cosine of the angle. And the vertical component f of y becomes the f multiplied by the sine of that angle. Now, let me give a simple illustration using a question of using this thing before we go further to exactly what we have for today. Now, the question goes like this. Now, I'll write it down. Let me try to write it down. It says, a nail on a vertical wall is pulled by means of a cord. So, I have a nail on a vertical wall is pulled by means of a cord. A cord is just a rope. All right, so don't mind the English. It's pulled by means of a cord attached to its head. Attached to its head. They now said if the cord makes an angle 60 degrees to the horizontal, if the cord makes an angle 60 degrees to the horizontal, and exert a force of 80 Newton on the nail, and exerts a force of 80 Newton on the nail. Now the question says, find the effective force which tends to pull the nail out of the wall. Find, a full stop there. So find the first one, the effective force which tends to pull the nail, out of the wall. And the second question says we should find the force which bends the nail. So we should also find the force which bends the nail. So just a very simple question to illustrate what I've just said. Remember, the question says a nail on a vertical wall is pulled by means of a cord attached to its head. If the cord makes an angle 60 degrees to the horizontal and exerts a force of 80 Newton to the nail, on the nail, the question says we should find the effective force which tends to pull the nail out of the wall, and equally we should find the force which bends the nail. So I'm going to sketch a diagram just for us to have a better picture of that question. Now let me draw a vertical wall. Imagine this to be a vertical wall, and this is just my horizontal base. Of course, the wall wouldn't be on air. All right. So let's say I have a nail being inclined here. So there's a nail being inclined at this point. This thing here is a nail. The way you nail, you can force a nail or drive a nail into the wall. That's exactly what we have here. Now, normally, if I want to pull out this nail, I should pull this way. I should pull straight. But because of whatsoever reason, maybe the height and other factors, I then use a cord to pull out the nail. And the cord was such that it makes an angle. So this is the cord pulling the nail in this direction. It makes an angle of 80 degrees with my horizontal. So this is 80 degrees, right? No, 60 degrees, please. So it makes an angle of 60 degrees with the horizontal. The horizontal is this dotted line I drew here. Remember, that would have been the normal direction to have pulled the nail, assuming I'm to pull it normally without a cord, just straight. But now, since I'm using a cord, the cord was exerted. The force on the cord is about 80 Newton according to the question, and then it makes an angle 60 degrees with the horizontal. Now, they want us to find the effective force which will pull the nail. Now, the effective force that will put the nail will be the force that will be acting on this horizontal line. So that is the horizontal component of the force. So how will I simply get that? I will know that my f of x becomes f cosine theta. Why? You can see that the angle is inclined to the horizontal. So the effective force f of x is equals to at, which is the force, multiplied by the cosine of the angle. And cos 60 is 0.5. 0.5 times 80 will give me 40 Newton. So 40 Newton is actually the force that will pull the nail out of the wall. Now, the second aspect of the question also said we should find the force that will bend the nail. The force that will bend the nail will be acting along the vertical line. So it will be the vertical component of the force. Still the same inclination. I'm going to solve for my f of y. All right. And then my f of y, we said, is equals to what? F sine theta. So it becomes f of y becomes 80, which is the force, sine 60. And then if I multiply, if I do 80 multiply sine 60, sine 60 should be 0.8660. Please, someone should help. You can press that with your calculator. What is 80 times sine 60? F of y becomes 80. Sine 60 should be 0.8660. So if I multiply 0.8660 by 80, what would I have? Someone should respond, please, so we can proceed to the next thing. 80 multiplied by 0.8660.
69.28.
That gives me 69.28 Newton. So this is the force that will actually bend the nail, because bending the nail will be acting along the vertical component. And then the force that will pull the nail out is 40 Newton, which will be acting on the horizontal component. So take note of this. All right. So having done that, or having established that, let's go to resolution of more than two vectors, which is where you might expect question. Most of the times you can see questions like this coming up in your exams. So let me write resolution of more than two vectors as a heading. Resolution of more than two vectors. All right. Now, to find the resultant of more than two vectors, what we do is that we resolve each vector into two perpendicular directions. I repeat that again. To find the resultant of more than two vectors, what we do is that we resolve each vector into two perpendicular directions. When I say perpendicular, of course, you know it's 90 degrees. So we have to resolve every vertical component should come on this single line. Every horizontal component should be on this single line. So it can either be like this, like this. How else? It can equally be like this and the likes. So it doesn't really matter how the direction faces, because the parameters given to us will determine the shape of our resolution. But the idea is that we have to resolve all the forces into two perpendicular directions, just like I've explained. All right, and then we add all the way to do that is to add all the horizontal and vertical components. Then we take their square roots of the individual, the square root of the sum. I repeat that again. We have to add all the horizontal and vertical components. Then we take the square root of the sum of the squares of those individual components. Now, let me just try to explain what I mean with an equation. Now, let's say we've added all the horizontal components and we got that all the horizontal components, our F1, remember we are dealing with, let's say, Fx. So Fx horizontal, I've added F1, F2. Let's say I have just 3 forces like this. And after everything, I got my horizontal component. Let's call it F of X. Then I added also for the vertical component, I added my F1, F2. I also added my F2. I will show you how we add this up. And then after adding up, I get, let me still write it as Fy. So these are the outcome of the vertical and horizontal component respectively. To find the resultant force, remember I told you in resolution, we find those two forces that will have the same effect with the resultant force. Last time we found the resultant force, which is that single force that has effect as the original two forces acting together. In this case, we are going to be finding those two forces that will have effect as the resultant force. So to find the resultant force, all I need to do is that my resultant force R becomes the square root of f of x square plus f of y square. So this is how to find the resultant of the vectors when I'm done resolving. The moment I finish adding up the components, the resultant becomes the square root of the sum of the squares of individual components. And then of course, since it's a vector, we need to equally know the direction. So how do we find the direction? The direction can be found by using the formula that alpha, which is our angle depicting direction, is equal to tan inverse of Fy all over Fx. So this is it. So take notes of these two equations or these two formulas. So let me just give us an example. Let's try to see how far we can go. But before then, one more thing before we solve an example. If I have my quadrant, of course, let me say I have my quadrant like this. This is my y-axis. This is my negative y-axis. This is my x-axis. This is my negative x-axis. If I'm trying to find the horizontal component of the forces inclined at this point, at the center here, let's say I have many forces. Of course, when I give an example, you understand what I mean by that. All right. Now I have many forces. If I'm dealing with the horizontal component, anything that falls on this plane is positive. On this quadrant is positive. Anything that equally falls on this quadrant is positive. But anything that falls on this quadrant here are negative. This thing happens if I'm dealing with the moment I start solving for my horizontal component. So I have positive, positive on the right, negative, negative. Any force on the left is negative. Any force on the right is positive. All right. But when I'm dealing with my vertical component, my y, this is my negative y, and then my x, this is equally my negative x. If I'm trying to find the vertical component, everything up here is positive and everything down here is negative. So take note of that. If I have forces that are inclined upward for the vertical components, they are all positive, then downward are all negative. If I have forces, in the case if I'm looking for the horizontal component, the horizontal component of the force, everything inclined on the right, just like you can see here, are all positive. Any force inclined on the left-hand side are all negative. So take note of that because it will really help us as we start dealing, resolving problems on this. See, Obaomi, I can hear you. What did you say?
Repeat it again.
I said, if you are dealing with, if you're trying to resolve these vectors and then you want to resolve the horizontal component of the vector. Remember, horizontal component is your x direction. Vertical component is your y direction. So if I'm dealing with horizontal, in this case, I say f sub x, where the f is the vector force. Everything on the right, any force inclined on the right hand side, this quadrant, remember, this is your first quadrant. This is your second quadrant. This is your third quadrant. This is your third quadrant here. And this is your fourth quadrant. Everything on the first and second quadrant is positive for the horizontal component. And then it is negative on, it is positive on the first and second quadrant. So anything that has to do with the horizontal component is positive for the first and second quadrant, but it is negative for the third and fourth quadrant once you are dealing with your horizontal component. But if you are dealing with the vertical component, 1 and 4, quadrant 1 and quadrant 4, any forces inclined there, the forces inclined at those two quadrants are positive, but the forces inclined at 2 and 3 are going to be negative. Remember, 2 and 3 are facing, that's the negative, they are tending towards negative y. 1 and 4 is moving towards positive y. But 1 and 2 is positive x, 3 and 4 is negative x. So take note of that, because so that the sign wouldn't confuse you the moment you start solving problems. That was the point I was trying to make out of the whole thing. All right, so let's look at this question. Now, the question says, calculate the resultant of 5 coplanar forces. Maybe I'll write it down. Calculate the resultant of 5 coplanar forces of values 10 Newton, 12 Newton, 16 Newton, and 15 Newton. No, 20 Newton and 15 Newton, acting at a point O as shown below. Acting at a point O as shown below. So this is the question, and they said I should find the resultants. Now, the B part also said, find also the direction of the vectors. Find also the direction of the vectors. Okay, so let's move on. Now, let me sketch exactly what they gave in the diagram. I have forces like this. Now I have one force inclined here at angle 50 degrees to the horizontal. So this 50 degrees here, and the force here is 12 Newton. And then I have another force inclined here, which is exactly at the horizontal line. We call that 10 Newton. They now give another force here, which is inclined at angle 30 degrees. And then they call there 15 Newton. And then they give another force here. And that force inclined at an angle 40 degrees. And then they call that force 20 Newton. So this is 20 Newton. So these are the forces. How many forces now? Okay, I have another one acting directly on the negative vertical, which is my negative y-axis, and they called it 16 Newton. All right, so these are the forces. These are the forces inclined like this. So they want us to resolve this vector into a single x-plane, a single y-plane, a single x and y axis. So what do? We have to consider their inclination. Remember, the formula I gave, we have to always take reference that the inclination must be with the horizontal. If it is not, then get the horizontal inclination. So let's label these forces. Let me label them. Let me call this one F1. Let me label anti-clockwise. Let's call this F2. Let's call this one F3. Let's call this one here F4. Oh, let me shift it a little. So let's call this F4. Then call this one here F5. So I've given a name to all this. Now recall that we have to resolve this thing to horizontal and vertical component. Now I told you, let's begin with the horizontal. For my horizontal, f of x is actually equals to f cosine the angle theta. So it implies that my f of x is going to be equal, let's start with f1. So I have f1. What's f1 here? F1 is just 10 Newton. Remember, f1 is this force here, 10 Newton. And 10 Newton, what's the angle 10 Newton makes with the horizontal? It makes angle 0 because it is simply lying on the horizontal line. Don't forget that 10 Newton is exactly on the horizontal line, so no angle is made. So I have f of x, I have 10 cos 0. That's the first one. Then I put my positive sign. Remember, everything on the right-hand side for the horizontal component is what? Positive. All right. So I go to my F2, which is still on the right-hand side for the horizontal. Remember, we are still dealing with the horizontal component, and everything on the right is positive. Everything on the left is negative. Don't forget. Now, F2 is 12 Newton, and 12 Newton makes an angle of 50 degrees with the horizontal. So I'll write that. So I'll have 12 cosine 50 plus, I'll go to F3. F3 is on the negative side, is on the left-hand side, meaning that the force there is going to be negative. So I have 20 Newton inclined with an angle 40 degrees to the horizontal. So I have negative 20. So let me put that in bracket, minus 20 multiplying cosine 40. Plus, I come down here, I have F4, which is exactly on the negative vertical. So you see, 16 Newton, the angle of inclination from that vertical line to the horizontal clearly is 90 degrees because from here to here, they are perpendicular. So 16 Newton is inclined at angle 90 degrees with the horizontal. Don't forget. All right. So I have that F4 is 16 cos 90. So I have, it's going to be 16 cosine 90. So next one, I have that 15 Newton here is inclined. Look at this. This 15 Newton, which is our fifth force, is not inclined to the horizontal, is inclined to the vertical. So if I say 15 cos 30, I'm going to be wrong. So I need to get what is the horizontal inclination here. Of course, if here is 30, here is going to be 60 without being told. So the horizontal inclination becomes 15 cosine 60. All right? Let me put it back. 60. So I have 15 cosine 60 as the horizontal inclination. So this is plus 15 cosine 60. So I'm done with the horizontal component. The next thing will be to add up everything here. Now 10 cos 0. Cos 0 will simply give me 1. 1 times 10 will give me 10. I put my plus sign. Now someone should help me. What is 12 cosine 50? What is 12 cosine 50? No one is saying anything. What is 12 cosine 50?
7.71.
7.71. So I write 7.71. Now plus minus is going to give me a minus sign. So what is 20 cosine 40? 20 cosine 40.
15.3.
15.3. I write it 15.3. Now I have plus. Cos 90 is 0. So that is 16 times 0 is 0. So I have plus 0. Then plus cos 60 is 0.5. 0.5 times 15 is going to give me 7.5. So if I add up everything and subtract, if I do 10 minus 7.1, 10 plus 7.71 minus 15.3 plus 0 plus 7.5, add up everything there, what would that give us? Please add up everything there. What would you have? 10 plus 7.71, okay, minus 15.3 plus 0 plus 7.5. What would everything give us?
9.91.
9.91. So I write down 9.91. So it means that the f of x, my horizontal component f of x, becomes 9.91 Newton. Now let's go back and get the vertical component, f of y. Now f of y in the diagram, you can see that your f of y, I'll say start from f1. All right, for the first force, I'm having 10 Newton sine 0, because that 10 Newton is just the inclination to the horizontal is just what? 0, no inclination at all. So I have 10 sine 0. Remember I told you if you are looking for the vertical component of the force, everything that is upward here is positive. The things that are downward on this side is negative. So don't forget that. So that by the time I start changing plus minus, someone doesn't get confused. So first of all, I have 10 sine 0, right? So let's call that a positive 10. So I have 10 sine 0. Then I put my plus sign, go back to the diagram. F2 is 12 Newton inclined to an angle 50 degrees. So that is 12 plus 12 sine 50. So I write it down, plus 12 sine 50. So 12 sine 50 plus, for F3, I'm going to be having also F3 is inclined to the horizontal. It's still at the top, right? Remember, we are dealing with the vertical component. So we'll be having, what's this, please? We'll be having 20 sine 40 for the F3. 20 sine 40, and it's still positive, right? So I write it down, 20 sine 40. I come down, go back again, plus, put my plus sign there. Let's check the F4 in the diagram. The F4 is downward. You see that? So F4 is 16 sine 90. Remember, that force is at 90 degrees to the horizontal. So I have 16 sine 90. So I write that down. So I have plus minus 16 sine 90. Then plus one more force on the vertical for the vertical component, which is 15 Newton. 15 Newton is at angle 60 degrees with the horizontal, which is 15 sine 60. That's what I'll have there. So 15 sine 60. That will give me the total horizontal component. So plus minus 15 sine 60. All right. Simplifying this, sine 0 will give me 0. So 0 plus 0 multiplied by 10 is still 0. No change. I have plus. Now, what is 12 sine 50? What is 12 sine 50?
9.2.
9.2. So I'm going to write down 9.2. Now I have 20 sine 40 plus, what is 20 sine 40? Twenty sine 40, what would that give us? It's obvious it's only one person is in the class. And as long
12.86.
12 point what?
Yes, sir.
86. So that's 12.86 plus 12.86. Plus minus is minus. Now sine 90 will simply give us 1. And 1 times 16 will still give me negative 16 back there. Plus minus is also negative. Sine 60 multiplied by 15. What would that give us? So what is 15 sine 60? Please check. 16 sine 60.
12.99.
12.99. So I write 12.99. So let's simplify this whole expression. 0 plus 9.2 plus 12.86 minus 16 minus 12.99. What would that give us?
Minus 0.94.
No, I disagree with you. 0.94. Go back. 0 plus 9.2 plus 12.86 minus 16 minus 12.99. It shouldn't be 0 points.
Minus 6.93.
Minus 6.93. So I write down minus 6.93. Minus 6.93 Newton. So this is my vertical component. So I found my horizontal component f of x as 9.91 Newton. Then the vertical component we found minus 6.93 Newton. Now the next thing we're going to do is to find the resultant force. And recall that for the resultant force, recall that our R, I said, is equal to square roots of f of x squared plus f of y all squared. So this means that our resultant force R becomes the square roots. What is f of x? That is 9.91. So I have 9.91 squared plus, then the vertical component is minus 6.93. So that's minus 6.93 all squared. All right. So evaluate the square root of this so we can get the value for our resultant force. What is our resultant force? So try to evaluate that in the calculator. What would you have? Ensure you put the negative number in a bracket the way I did, so you don't get math error. The negative number must be in the brackets so your calculator doesn't understand it differently. So press this like this if you have a good calculator. If you don't, do it bit by bit, get the value of R and tell me. Please, it doesn't mean that only one person should always respond. You guys are more than one. It's obvious we have persons in this class, but you guys are already used to not responding to your classes. Please, what's the
12.09.
answer? Is what? Say that again. I didn't hear you.
12.09.
12.09. So our resultant force is equals to 12.09 Newton. So that's the value of our R, 12.09 Newton. I found the resultant force. That's it. The next thing I'm going to do is to find the direction. Remember the equation says, let's go back to the equation. The equation says we should find the resultant force, and then we should also find also the direction of the vectors. After we found the resultant force, we have to find the direction. Then the next thing will be to sketch that diagram. Even though they didn't ask us to sketch, but I will sketch it for you. All right, so let's find the direction. How do we find the direction of the vector? Very simple. Remember I told you to find the direction of the vectors, we use the formula that alpha, which is the angle that talks about the direction, is equal to the tan inverse of your f of y all over the f of x. Please ensure, this has to be in absolute value. These two values must be in absolute value. So it doesn't matter whether it is negative or positive, absolute value makes it positive. All right. So we don't consider negative sign in this evaluation. That's the point I'm trying to make. All right. So our direction, which is our alpha, becomes the tan inverse of our f of y. The absolute value is simply 6.94 divided our f of x, the absolute value is simply 9.89. So please help me check what is the tan inverse of that fraction there. 6.9, this is 9 actually. Oh my God. Come on, terrible. So what is the absolute value? The tan inverse of 6.94 divided by 9.89. 9.91, please. You said 9.91, please. 9.91, that's what you got, not 9. Please, let's correct that, 9.91. And then the other one, you said you got what again? 6.93. So this is actually 93. So please press that again about me. Press the tan inverse of 6.93 divided by 9.91 and check what you will get. It wouldn't be far from what you just said right now. The tan inverse of 6.93 divided by 9.91. You can choose to evaluate the fraction first. Anything you get, you now press the tan inverse, depending on the calculator you are using. Be very careful so you don't get wrong values. So please, what is the direction? Once again, what's the value of alpha? If you press your calculator, what is the tan inverse of that fraction there? I'm still waiting for someone to respond.
34.96.
34.96. 34.96 degrees. So permit me to approximate this to 35, that's nearest whole number, 35 degrees. And this is my direction. The next thing I'm going to do, I'm done solving the question. So I found the direction. So these two forces is actually, the resultant force we found is actually inclined at an angle 35 degrees with the horizontal. You see that? So I can sketch this vector, the two components, and then sketch my resultant force the way it is. So if I'm going to sketch the vector, I have the horizontal component, which is 9.91. It will be longer. 9.91 should be, this is my 9.91 Newton. Right? Then I have also minus 6.95. The minus sign simply means that instead of the y axis to go upward, which is positive side, it has to come downward. That's the reason for the negative side. So let's stop here. So this is, I'll just write the 6.93 that we have. 6.93. So 6.93. No need for the negative sign, because the negative sign tells us the direction. That's all. And then the resultant force should be in between, acting this way, is longer than the two other forces. And we calculated it and found 12 points. Let me check. 12 points. 12 point what? 12.09. So our resultant force is 12.09. 12.09. And the angle of inclination we found, which is direction of the vectors, is going to be 35 degrees. So this is actually the angle with which the resultant is inclined to the horizontal, which tells us about the direction of the vector. So this is the solution to that question given to us to solve. Does anyone have a question, or you're confused at any point, so I can explain again? I ask again, does anyone have a question? If in the absence of no question, it means you all understood the concept very, very, very clear. All right. So, but just by way of recap, we don't have time to solve another question. Let me just throw light. This is a question given to us. They said we should calculate the resultant of 5 coplanar forces of values 10 Newton, 12 Newton, 16 Newton, 20 Newton, and 15 Newton, acting at a point O as shown below in the diagram. And they said we should find also the direction of the vectors. And this happens to be the diagram they gave to us. And then we have to then resolve the horizontal component using F cosine theta, where theta is an angle inclined to the horizontal. And we said if the angle is not inclined to the horizontal, you need to get the horizontal inclination. All right. So F cosine theta, we did that for each of the forces individually. So we have 10 cos 0, which is this force here, F1, inclined at angle 0 because it is exactly on the horizontal line. And the angle must be made with the horizontal. So no angle has been made. That's why we have F cos 0. Plus, for our F2, we are having 12 cosine 50. That's what we have there. Then plus, the other one becomes negative. Remember, I told you for the horizontal component, everything on the... What did you say about me? Okay. For the horizontal component, everything on the right-hand side is positive. Your network is glitching. The what? What did you say? Maybe at the end of this class, you can try to just reach out to me personally. I can't hear. Your network always breaks. You can just try to send me a DM. All right? For the F1, do you mean F1? Why I didn't put F 50 degree for the F1? Oh my goodness.
Yes, sir.
If that's your question, okay. If that's your question, it is because 50 degrees is not inclined with F1. 50 degrees is actually inclined with F2. You can see it was the 12 Newton force, which is F2, that made the angle 50 degree with the horizontal. The 10 Newton force is lying on the horizontal. There is no angle being made since the force is actually on the same horizontal line. All right, the angle must be subtended with the horizontal line. That's the point. And F1 is just on the horizontal plane, no angle made. So hence, that's how we got F cos 0 there, which is 10 cosine 0. And then we did 12 cosine 50 for F2. then we came to the other side, which becomes negative for the x value. We then have minus 20 cosine 40. Then downward, we have 16 cosine 90. Then we also have 15 cos 60. And then we simplified everything. We got that our f of x equals 9.91. Then for the vertical component, we repeated the same process. We did 10 sine 0 for this force here. For the F1, 10 sine 0. Remember, the idea is that for your vertical component, the formula is f of y equals f sine theta. That's it. Once you are looking for the vertical component, this is the formula to use in solving it. So we have F1, which is 10 sine 0 plus 12 sine 50. Then still plus, I have 20 sine 40. Then if I come down, it is no longer on the positive y. I have minus 16 sine 60 sine 90, because from 16 to 90 to horizontal line there is 90 degrees. See that? So this is 90 degrees. All right. So I have minus 16 sine 90. And then I equally have the last one, which is minus 15 sine 60. And that was what we did, and we arrived at this point. All right, so everything we added up became minus 6.93 Newton. And afterward, we found the resultant force by simply taking the square root of the sum of the squares of those individual components. And that's how we got that the square root, which is the resultant force, became 12.09 Newton. The next thing for us to do would be to find the direction. And in finding the direction, we need to consider the formula that the direction alpha is equal to the tan inverse of f of y all over f of x, where the f of y, f of x must be in absolute value, so we don't bring in a negative sign. That's the idea. All right. So if you check, f of y has a negative value, but minus 6.93 in absolute value is actually positive 6.93. That's why we have the tan inverse of 6.93 divided by 9.71, and we got 34.96, which is approximately 35 degrees. Then the next thing for us to do will just be to sketch the diagram according to scale. So everything you are sketching must be, at least it has to be such that the longer lines you have, the longer vectors should take up the longer lines, and then vice versa, just like that. And that is that for resolution involving more than two vectors. So let me give you the one you do, just the one you use and practice. So I'll simply sketch the forces like this. I have one here, I have one this way, I have one this way. I'll put in their values. I have one this way. So I have here to be let's call it maybe 12 Newton. Then I have here to be let's call this 15 Newton, and is inclined at angle 30 degrees here. Then I also have here, which is, let me incline it to the vertical. Of course, you need to know the horizontal inclination. And then let's call the force 20 Newton. And then I have another one here and also here. And then the one pointing downward, let me call it 25 Newton, which makes angle 90 with the horizontal. Now let me call this one, let me incline this one also to the vertical. So let me call this maybe the angle there, let's give it 60 degrees, and the force should be about 30 Newton. So this is the diagram. Is your assignment. I want you to practice how we can resolve this into single x plane and a single y plane, and then at the end equally find the direction of that resultant vector. You need to find the direction of that resultant vector using exactly the method we deployed. So take down the question, and that will be all for now. I don't know if anyone has a question. Does anyone have something he or she doesn't understand and then you want further clarity? Even though our time is actually up. Or ask your question if you have any. I know you guys are not, you just like seated and that's all.
But my next
Okay.
is bad.
You what? I didn't hear you about me. Please, I think that will be all for now. I can't get what you're trying to say about me. If you feel I'll attend to that. Okay. So for now, see you at the end of see you in the next class to have a good evening.
Thank you, sir.
I
All
said
right.
that I have, but I cannot say it here because my network is bad.